This conference will now be recorded.
Okay, so as we had in the last session for thread dumps, so we would be discussing about heap dump in this session. Okay, so let me just quickly minimize this. Okay, so this is the topics that we are looking to cover in this heap dump session. So first we'll understand what is heap dump, then why do we need to take heap dumps, right? Then there are different types of heap dumps. So what are the different types that are right now available in the market? Then we will see how do we take a heap dump again on the same lines that we discussed about thread dump. So using some command line options and using the tools. And the last topic would be analyzing the heap dump. So this is some slightly larger topic. So we will discuss in next session. So today we will cover the first four topics. Okay. So first is what is heap dump, right? So this is the definition that I took from this Oracle Java website. So it's nothing but heap dump is a plain snapshot of your memory of all the Java processes or a single Java processes running at a certain point of time, right? So when we take a heap dump, so we take it for an entire virtual machine, so entire VM. So in simpler words, a snapshot of a JVM at a particular point which collects only the memory objects, whatever the memory of that particular JVM is at that point of time. That entire snapshot is your heap dump. So what does it connect? So it has different formats. Okay, so depending on that different format, it also contains different types of information. Right. So for first, the general information in your heap dump you will find is the total number of Java objects and classes that are loaded in your heap or that are present at the moment when you're taking a heap dump. Right. And depending on the different types of format, you can also get the information about threads and all these things. Okay, so we will see that when we take a heap dump. I will show you guys that. Okay, so one more thing that we need to understand that heap dump is specifically a snapshot of memory, and it's taken for a particular point of time, right? So it does not necessarily include the information about the object or allocation, right? Or the method for in which the object was allocated and like that. So this is some kind of minute information which will not be there in the heap dump, right? So this is just one point to remember. Okay, next, coming to the next point, why do we need to take heap dumps, right? So right, as of now, we might have heard in our industry like uh, have you done heap dump analysis? If there are memory issues, take heap dump. Memory issues, take heap dump. But what are the different other things that heap dump is useful, right? One thing we know that to analyze the out of memory error, but apart from that, what are the different things you can do it? So first, as you already know, so if your application is crashing, periodically, like so, just you started your application, it kept running for 10-15 minutes, and after that it's crashing. So in that case, it is again always advised to take the heap dump of application and then try to analyze why the memory utilization is getting increased. Again, this out of memory error, when we see this out of memory error, so there are multiple causes for this out of memory error. We have already seen this in the previous slides when we studied about the JVM, right? Heap area, right? So because it is an out of memory error and heap dump gives you the snapshot of the memory, so it would be always the first choice to look for. So what is an issue, right? So you can look for what are the number of objects are available which are taking space, and depending on that, depending on your analysis, that larger size taking objects, and whether these objects are statistically present in every heap dump and land. So this kind of things you can do for start. You can start with analyzing the heap dump for your out of memory error crash. Okay. Second thing is heap dumps are useful for to identify the footprint of memory footprint of your application. Okay, so now when it is required, so when you might have heard about that, I want my application to scale up, or I want to perform a capacity management of application. I want to figure out how much resources I would need if I want to extend or expand my application user base from X number to some point, right? So in that case, you will need the CPU footprint, the memory footprint of your application. So what is memory footprint? It is nothing but the uh, you know it memory footprint of your application is nothing but a particular size of memory or particular sections of memory that will utilize for a particular user base or particular load, right? So heap dump also helps you to get or analyze the footprint of memory, and it will also able to help you that what are the objects in your memory which are taking up sizes, which how many objects are with big structures, how many the classes are with the redundant data structures. So this kind of information can be gathered from your footprint heap dump also. Okay, then next you have there is the last point is that when too many garbage objects are collected. Okay, so as we already discussed in the first thing that in heap dump we may not necessarily know that the information that when an object is allocated or in which method it is the object will allocate. This information is not there in heap dump. So unfortunately we will not be able to find out that why there too many garbage objects are produced during a certain operation, right? So for that that is actually a thing of profiler. Okay, so for this thing we need a Java profiler or J profiler on your application, which will actually capture the methods which are creating the objects. In heap dump it is at the latter part which is actually created objects are residing in the memory and that we are capturing. So in order to get that idea that why so many objects are getting created garbage, right? So this kind of technique, so you need we need to have a profiler. Okay, so it will also not be advisable to just try to identify, try to reduce the memory leak depending on the leak detecting techniques or just analyzing the heap behavior. So these are some few reasons for heap dump, that why do we take heap dump, and what are the reasons that we just not to be, we should not only depend on the heap dump analysis. Okay, so now there are types of heap dumps. Okay, so there are different types of heap dumps. We only know that HPROC binary heap dumps, right? But depending on the JVM or depending on the VM machines, there are different three. We can categorize into three different types. First is your HPROC binary heap dumps, which is generally your produced by your Sun JVM, HP, SAP, and other JVMs. Okay, then you have your IBM system dumps. So whatever the machines, if your systems are working on IBM VM, so it will produce IBM system dumps. And there are some IBM portable heap dumps. They call it as a PhD. Okay, so this portable heap dumps are capable of containing some useful information, and also these are easy for they are easy to transfer from one place to another place. So that's why it's called portable heap dump. Okay, so we will just go line by line and we'll just see what is the HPROC binary heap dump. So what kind of information it contains. So this is the most general, or what we can say most generalized heap dump. Okay, HPROC binary. So this contains the information like for every class HPROC for every class, the HPROC dump contains its name, superclass, its class loader, defined fields for instance name, and the static fields for the class and their values. So this kind of information about the classes for all the loaded classes are there in the memory. HPROC will have it. Then about all the objects. So once first classes are there, so it comes in a hierarchy. First you get classes, then you get objects. So under every class, how many objects are there? This all information will be available in the HPROC heap dumps. Apart from that, a list of GC roots. Okay, now what's a GC root? This is an also important concept when you are trying to analyze heap dump. Okay, so a total list of GC roots will be there in hprof heap dump plus the call stack of all threads. Okay, so this has been introduced from after the JDK 6 update 14, and now all the JDKs above JDK 6 have the call stacks of the thread in your heap dump. Okay, I will also show that when we take a heap dump. Okay, next is your IBM system dumps. Okay, so as I already said, if your application or your application is running on IBM website application on IBM VM or IBM platform, so it can produce or it can be process a system dump. They call it as a core file. Okay, so they extract this core file from the Java process which is running on your IBM platform using the JExtract. So JExtract tool. There is a tool to which they use to extract this dump information core file and analyze these results with the. You can analyze these results afterwards with your memory analyzer or any other on any other machine. So right. So what does that core file or that is extracted from this JExtract tool, what does this file contain? So it is not necessarily similar with this hprof, but it will also include the information which is needed or which will fulfill your analysis for heap dump. Okay, so it also includes your all the field names, your primitive fields, stack trace, and etc. Also that is with this we also have process related information. Okay, so this process related information will not be used for your analysis, but it's a side load you have with this IBM system. Next, you have IBM portable heap dumps. Okay, so the name already suggests is portable. That means they are very small in size, and that's why if when we have smaller heap dump in size, it contains less information. Okay, so the major difference between your hprof and this PhD is that this portable heap does not contain the values of primitive fields. Okay, so only the non-null references from an object are provided. So that means only the live objects whatever in your JVM are or at the running point of time when you take the heap dump, these objects are provided. Apart from that, no other objects or no other fields will be reported in your PhD. Okay, then the second important difference is that your field names are not present. That means one cannot distinguish between a field reference is made, and because of this, its present reference chains are not as concrete as with the other dumps. So for what happens over here is, if when you take consecutive heap dumps on this PhD, consecutive portable heap dumps, so and this consecutive portable heap dumps you will not be able to correlate and you will not be able to map a particular field with another heap dump in the same heap dump or in the newest heap dump. In case of hprof and the IBM system dumps, we can at least because they have primitive fields included in it, so we can at least map the primitive fields from one heap dump to another heap dump and compare it. But in this case, because we don't have the names of field, it will be very difficult to compare and it will be difficult to distinguish between the reference. I mean, which method or which call or which class has been, holding this particular object like this. Okay, so but the information that PhD is having, this just an object graph that how many objects are reference and how many objects are live. So that information is enough to analyze the memory related problem. So you will at least have a get hand of that what is the memory footprint, how many objects are allocated in the memory, and what kind of structure of objects are, how many string objects are there, character integer, and like it is segregated in different types of format, and you will get an object graph. Also you can list the objects by the sizes in this term. Okay, now whenever a PhD dump you're generating, so with this PhD dump there is corresponding a core file generated with this. Okay, so if this core file and this dump file is you place it together, and when if you open it with a memory analyzer, then some of the data from the core file can be used to correlate or relate the things that you already have in the dump file, PhD file. Okay, so I mean this is kind of the information. But so nowadays, everything is on distributed architecture and everything is on cloud, so you will not most probably see this kind of dumps, portable heap dumps. But they have provided you the enough virtual space to analyze your memory problems then and there only. Okay, now coming to the point that how do you take a heap dump, right? So same lines that we have discussed in our thread dump session, right? That how do we take the heap dump using command line attributes, plus how do we take a heap dump using different types of tools. So first we are discussing about this command line options. So there are few commands which can be used to take heap dump. So first is your jmap. Okay, so jmap is the very famous, available in your jdk bin folder. You can go and check, it is available in the jdk bin folder. So there are three basic attributes you need to provide to the jmap. First is your format. Okay, so jmap, most of the time format you are going to use is binary. So jmap hyphen dump colon format b. So you can see that I've just tried to give an idea that how this command is going to be used. So jmap dump format is b is binary. Then file path is nothing but the path where you want to save your heap dump. Okay, so this is an uh, what do we say, it's an critical argument that you have to give this argument. If you're not giving this argument, your file will be stored on your bin folder path, so jdk bin directory. Okay, then you need a PID of the process, PID of the Java process, where whose heap dump you want to capture, right? So these are the main three arguments you need to have on your jmap command. Plus there is one more option available. Okay, so jmap will capture this heap dump with these three arguments, no doubt. But this kind of heap dump will also have some non-living objects inside. Okay, so what do you mean by non-living objects? That means so we all know that whenever we are taking a heap dump, first thing system is doing is it will be calling a gc, right? So the purpose of the gc is that so it can collect the all the garbage pieces or all the objects which are not referenced, and there should be only live reference objects which are which will be there in the memory, and it will help you to analyze the memory situation better, because all the null reference objects or all the garbage objects will be collected already. But if you just capture the heap dump with this option and without giving the live option, it will also include the null objects, null reference objects, or the dead objects. Okay, so it is also required, so you pass this live option in the so how do you pass this live option? So in jmap command there is one more argument which is called histo. Histo is nothing but histogram. Okay, so this is for histogram. So when you use jmap, you add this after pid, you add hyphen histo, and in bracket you mention it live. So let me just show you how that's option is, and you just need to type jmap, you will see this. Yeah, you can see over here histo colon live. So once you have all this information like your process id and the path where you want to store your heap dump, you just need to append this command with hyphen histo, and in bracket you just mention live, so it will only collect the live objects. Okay, so that is one thing. Now there is one more thing that is followed, which it is a followed practice in industry, is to capture your heap dump. Just a second, I think I scrolled up. Okay, so capture or heap dump when an out of memory or error occurs. Okay, so for this particular thing, when you need to capture or heap dump whenever an out of memory memory error is there in your jvm, you need to configure your jvm or java options with this particular flag, or what we can say a particular Java option. So hyphen xx colon plus heap dump out or heap dump on out of memory error, and you give the path. Okay, so this is advisable to have configured at all times for all the applications. Okay, because you never know when you will be getting out of memory error on your JVM, right? So it is always handy. So whenever your out of memory error is error occurs in JVM, it will automatically keep a heap dump, and it will be helpful for you to analyze this situation. Because in case if you don't give this option, there will be no there will be no solution, and you will be left stranded to analysis to find out the problems, that how why the out of memory error was caused, right? So then there is one more command, jcmd, that we already seen in red dump. So jcmd is a very helpful command. So it is actually, it involves for all the Java operations on you can perform on JVM. So jcmd is a, like, it's a mother jar, or you can say motherboard of your JVM. You can access all the things using jcmd. So to capture heap dump using jcmd, you just need to enter the command jcmd gc.heapdump, and then you need to mention the PID, process ID, right, for which you want to capture the heap dump. Okay, so this is the way you can do it using command line options. Then you have tools. Okay, so using tools, as of now we already studied JVisual JConsole, and JMC, Java Mission Control. Apart from that, there are other monitoring tools are also available, right? So which gives you an additional hand capture the heap dumps while you're running or while you're monitoring your test. So using JVisual VM, I have just listed steps for using JVisual VM. So you can just launch JVisual VM. We know how do we launch it. You check which processes are running and just click on the heap dump. Okay, and once you click on the heap dump, it will automatically open a heap dump in a new tab. Okay, and if you want to save that file, you can click on that heap dump, and you can save this file as save as heap dump, and give the hprop extension, and then you can use the same heap dump file to analyze in different application. Okay, so JVisual VM also gives you an basic summary or basic idea about heap dump. You can also read your heap dumps in JVisual VM, but it is not that much user friendly, or it is that much understandable as compared to the other heap dump tools. Okay, now there are different types of JMX clients are available. So JConsole is one of it that we can use to collect the heap dump. Other than JConsole, you can have JMXH, Java Mission Control, that we already heard about it, JMC. So this client we can use. So these JMX clients, how do they capture the heap dump? Is basically they use this particular MB. So com.sum.management dot type is equal to hotspot diagnostic MB. So this MB is this MB will be used in all these JMX client. So this JMX clients have dump heap operation. So once you connect your JVM using JMX or JConsole, they will you can create a heap dump using this MB option. Sorry. Okay, then there is last thing, which is a programmatic approach. Okay, so what is a programmatic approach? So this also uses the same thing. No, because from the JDK6 and JDK8 above, you have this MBs provided. So all this MBs, what you need to do is you just need to write a simple snip of code which will generate the heap dump. So it will again on your demand, I mean how you want to generate the heap dump. So as we already previously said that when out of memory error occurs, you want to generate a heap dump, or for example if there is a particular issue that you want to trigger a heap dump for, so you can write it a small snippet, a small code. This particular code is also available on Oracle site. Okay, so sample code is available in Oracle. You can enhance that code, or you can integrate the same code in your application. And whenever your application is running, this code will be also run. And whatever the criteria you define in your code, in that way, your heap dumps will be taken. Again, it uses the same methodology. It is the same MBs, because it has exposed the JMX ports. Okay, then for IBM tools. Okay, so we also seen that, apart from Sun, Java, and different vendors, IBM also have some VMs running. So for IBM application, if your application is running on WebSphere, you can use the administrative console. Okay, so whoever has worked on WebSphere, they must know that there is a WS admin console, right? WebSphere admin console. So in WebSphere admin console, you get all the list of list of the different options where you can also connect, where you can also generate the heap dumps. So the steps I mentioned over here. So you can just start administrative console, then navigate to the troubleshooting panel. Okay, troubleshooting and Java jump and Java dumps and cores, and then select your server and which you want to generate the heap dump. Just click on the heap dump, you will get the heap dump of your particular server. Okay, then so these are the different types of options that we have discussed for this, taking the heap dumps. So though we have so many options, but the famous options like are JMap. Most of the time people will use JMap or heap dump on out of memory error. So this is already configured. And third option is your JCMD. So JCMD also will not be used too much. So nowadays people are preferring to use the APM tools and different types of monitoring tools. So JVisual VM, if you have set up, so they will capture the heap dump using JVisual VM only. Okay, so no one is bothered to go to command line, find the Java process ID, and capture the heap dumps. So all wants to have the sophisticated ways to capture heap dumps. So why don't you use it like that? Okay, so this is the things for today's session. In tomorrow's session, we will see that how do we analyze the heap dump. Okay, so before we conclude this session, I will just show you that how we can take heap dumps first. Then the analyzing part we will discuss tomorrow. So let me just quickly start some our application, right? So I can show you that how we can generate a heap dump. Okay, so I've started my Tomcat server. So I'm expecting my application will be started up. So I will just launch the JVisual VM. Okay. So I've just launched the JVisual VM. I can see this Tomcat PID. So this is my application. Just double click it. Okay, so it is running now. So you can see different types of JVM arguments that have been passed for this application and all the things over there. You see in the monitor visual GC. Okay, so when using JVisual VM, as we already discussed, you just need to right click and you need to click on the heap dump. Okay, so as soon as you click on heap dump, it will generate a heap dump. Okay, so this heap dump is generated. Now you can see this is the just basic summary of heap dump, what all the things are there. Then classes, then you got instances. At first it will show nothing. So for to see the instances, you need to get click on the classes. Just right click on any of the class and click on show in instances field. So that particular class, so we have just click on the character class, right? So character class will be showed in the instances field. That means it will list out all the instances of this particular class and what all the values that it is containing. So for example, like you can see over here, just arrange this column so you'll be able to see. So this particular class, you can see, I just expanded. So it has 500 items. Why I'm not able to see any value over here? Yes, you can see over here. These are the values inside. Okay, but so if you want to read it, it is not in human readable format, but these are the codes or some kind of symbols that are used in application. So this is again in binary format. So the representation way is from it is converted into the ASCII format. So that's why we are not able to uh, read it in a it is not in a human readable format, but it just gives you the information about what are the different types of objects, or what are the different types of values for each your character is allocated. Same way, now this is the one method you can you generate a heap dump. Then as I said that this is Tomcat PID. Now we know this is the Java process that we want to do. So we'll also try to capture it using JMap. Okay, so what first process is, you find the Java process ID, use command JPS for it. So in JPS you can see it has listed some processes. So we know Bootstrap is our Tomcat process ID. This is the process that we want to capture the heap dump. Now you put jmap space, okay, hyphen down colon format equal to b, right? Hyphen down colon format equal to binary. Then you give comma. And you have to give path, file equal to file path. So we'll just copy this particular path. Training. File equal to sample dump. Then we also need to give extension .hprof kind of thing. Okay, space. You just need to give the process ID, that is 26560. Okay, then hyphen colon something is missing. Okay, so hyphen s2 should be before the query. Six four six zero. So this is not working. Let me just come back to you guys on this tomorrow. So I'll just try to modify the command, and we will discuss how do we analyze the heap dumps once we take these heap dumps using different options. How we can analyze. So this is for today's session as of now. So please go through the recording, and if you have any questions, let me know. So this analyzing heap dump part we will cover in next session. So that would be most probably day after tomorrow. I
Yeah,
will send an email.
I have
Yes,
only
Anand.
one question here, maybe.
Tell me.
So actually evoking heap dump it enhances our memory and CPUs. Is that the essence only, or it has a positive effect on the entire application under the hood of our
Okay, so there is yeah. So as we discuss, there are different types of objectives you can take heaped up. So first is performance tuning is one thing. So if you are observing your out of memory errors and the different types of issues are there, your JVM is covering. In
Okay.
that case, it would be good start to start from heap dump, analyze the heap dump, try to find out how many objects are highly sized or major objects or major classes which are having high footprint memory footprint to your application, which is causing your JVM to slow down. Okay, then second thing is that you can also identify that how many objects are there which are redundant in the application, right? So you might remember that in one of the sessions we discussed so how heap dumps will help. Okay, so for example, if your application is crashing continuously and you are not sure that what is the reason, so what you need to do is you need to perform three heap dumps. Okay, so first thing is that as soon as you start your application and there is no activity on an application and it's an idle state, you capture one heap dump. Okay,
Yeah.
second, you let your application running, let some activity be going on that application, let that application be loaded, and let that let the application have to be in a business as usual model or business as usual mode. Then take a heap dump, and the third heap dump you need to take is when your application is facing issues, when your application is slowed down or you're facing out of memory error in your application. At that time you take the third heap dump. Okay, once you have all these three heap dumps, what you want to do is you need to compare the three heap dumps. Okay, so this kind of comparison will give information that which are the objects or which are the classes are actually required for application to process up, and which are the classes are actually consuming high spaces or high memory footprint in your application, which is causing the issues. So this is the way that you use to analyze the memory related issues.
Yeah,
Okay.
yeah, yeah. Thank you, Shita. And my engineers are always saying it's not always advisable to actually create heap dump. They say it's costly, stuff like that. Is that
No,
okay?
no, it's not like that. Uh, See, heap dumps are only necessary, or it is only required to take the heap dumps when you are facing issues with your application, right? So that's why we have this heap dump on out of memory error message, because whenever you are taking a heap dump, what process follows is that once as soon as you trigger a heap dump, you will be getting a GC call. Let me just check if we have just tried to collect a heap dump. Let's just check in the GC graph. Now it's already passed. So as soon as you try to collect the heap dump, a GC is called. So that's why it is not economical to take multiple heap dumps, right?
Okay,
Unnecessarily.
okay,
Okay, but it is a very good point to have your heap dumps, in place. This kind of commands in place, so that your application automatically collects the heap dump whenever there is an issue. So this option is available in all the JMX -xx heap dump on out of memory error. Okay, so this has to be enabled, and usually this is enabled in every application, or all the applications you can see this option is already enabled. Same is with the GC logs, so they are already having this options enabled to debug, or to find out the problems in future. If you have any problems with application, this options will be there. So it is not advisable. That is correct, that whatever you are saying, because it is costly. So how it is costly, that I am telling you, because taking a heap dump causes a GC to run, and we all know that GC is costly because it will stop your application processes, the business processes, and it will also consume some CPU. Plus whenever you are taking a heap dump, it will also need some memory space, right? So this memory space also will be consumed. So consecutive heap dumps is not an advisable manner, or it is not advisable to have consecutive heap dumps, but only when you are pretty certain about some issues, and when you're debugging or when you're trying to figure out the issue with application, then only it is advised to take heap dumps and particular occasions and then try to compare it, right?
Okay, great.
Okay, so I think that's all for today's session. Tomorrow we will see what are the different types of tools we can use, to compare the heap dumps or analyze the heap dumps. So JVisual VM, we already see that JVisual VM also gives you a good idea about heap dump, but this is not in a readable format. Or someone like newbie, we cannot actually understand what the information is over here and what do we actually need to look out, right? So there are other tools like MAT, memory analyzer, and there are Heap Hero. So this kind of tools we will discuss in the next session, and we will also discuss that what are the specific issues that we can capture from the heap dump. Okay.
Right. Yeah.
So concluding this session, thanks for attending, Sanu.
Thank you so much. I really appreciate you. So you're so focused. Thank you so
Yeah.
much.
Thank you. Thanks, Sanu. Bye bye.
All right. Yeah. See you tomorrow. Bye.
Bye. So it will be not be tomorrow exactly. I will send you the invitation. So it would be day after tomorrow. So today is Thursday, right?
Mhm.
So maybe Saturday early morning over here. So that would be Friday night for you. So I will update the invitation and I will send you out.
All right. All right.
Okay.
So after the heap dump, I think we're gonna is gonna be is it where there is this topic which I told you about the other day, which is
AWR. Yeah.
yeah
Yeah.
AWN.
Yeah. So after this hip dump is done, we are covering that only. We will be
All
going
right.
to AWR.
All right. All right. Thank you
Okay.
so much. Yeah.
Okay. Thanks. Bye bye.